Welcome to the Explainer. Let's just jump right in, shall we? Today, we're diving straight into the absolute brilliance of aviation physics. Instead of just marveling at how a massive commercial airliner somehow gracefully leaves the runway, we're going to dig into the actual mechanics outlined in our source material. We really want to see exactly how four specific forces create lift. Because, spoiler alert, it's not magic at all. It is pure, incredibly elegant, and highly structured physics. So, let's get into it.
Section 1. The impossibility of flight. Okay, so our source material boils this whole gravity-defying battle down to exactly four invisible forces: weight, drag, lift, and thrust. Think of it kind of like a continuous, incredibly high-stakes tug-of-war. You've got gravity, which is our weight, and drag constantly fighting to keep the plane grounded and slow it down. But then, on the flip side, lift and thrust are the human-engineered counters that make flight possible. When these four forces are perfectly balanced, boom, the airplane maintains its flight. When they're manipulated, the airplane changes its behavior. Literally everything about aviation comes down to understanding and controlling these four forces.
Moving right along to Section 2, creating lift with wings.
So what does lift actually mean in this context? Well, it's the force created by wings changing how air moves around them. And the really fascinating part here is that word changing. The wing isn't just sitting there passively. It is an active manipulator of air molecules, generating this massive upward push that fights directly against the downward pull of gravity. Honestly, without this active manipulation, our massive metal machine is just a very heavy, very fast bus.
It really all comes down to geometry. Because of the curved shape on the top of the wing, the air up there is forced to travel differently than the air moving across the flatter bottom surface. This difference in movement creates pressure differences. Specifically, you get lower pressure on top. And since high pressure always wants to seek out low pressure, the air beneath the wing physically pushes up, trying to reach that lower pressure area. That relentless, powerful upward push, that is lift. That invisible pressure difference is exactly what's holding you up when you're cruising at 30,000 feet.
Section 3. Engines and forward thrust.
But here's the thing. Wings absolutely cannot do their job sitting still on a runway. As our source notes, the engines provide thrust, pushing the airplane forward through the air. That forward drive is what feeds the wings. Whether we're talking about massive jet turbines or spinning propellers, their violent push forward literally pierces through the air resistance. The faster those engines push the plane forward, the more air rushes over the wings, which maximizes that crucial pressure difference we just talked about. Basically, thrust is the ultimate enabler of lift. They work together in this beautiful, synchronized partnership. Which brings us to Section 4, controlling the aircraft. So how do pilots actually steer this thing while suspended in what is essentially a giant fluid? It's a brilliant little chain reaction. Step 1. The pilot adjusts these small, movable surfaces on the main wings and the tail. Step 2. This instantly changes the airflow around that specific part of the aircraft, acting almost like tiny localized wings. And then Step 3. This localized pressure difference tips the balance of our four forces, tilting or turning the entire plane. It's crazy to think about, but a tiny physical adjustment controls a vehicle weighing hundreds of tons. It is just an incredibly elegant system of cause and effect.
Well, we've covered a lot of ground today, or actually scratch that, a lot of sky in this explainer. We've seen how the sheer brute force of engines creating forward thrust works in perfect harmony with the elegant curve of the wings generating lift through pressure differences. And we've seen how pilots masterfully manipulate these invisible mechanics using tiny control surfaces to navigate all around the globe. So I want to leave you with this question to chew on. The next time you fly, will you feel the four forces keeping you in the sky? Seriously, the next time you're accelerating down the runway, pinned back in your seat, I really want you to feel that engine thrust pushing you forward. As the wheels leave the tarmac, try to visualize the air accelerating over the curved top of the wing outside your window, creating that low pressure, and the high pressure below physically pushing the aircraft up into the clouds. Flight isn't magic, and it certainly isn't impossible. It is a stunning symphony of physics. I really hope this explainer has given you a completely new, scientifically grounded perspective on the invisible forces at play every single time we take to the skies. Keep learning, keep looking out the window, and hey, thanks for joining me.